Today our objective is to complete review assignment number 11, which is the Hattori puzzle page. This is just a little bit different version of the game that we saw when we went through the tutorial. There you can see it a little bit better. So, very similar in the sense that we've got 3 buttons up here that allows the user to select a different puzzle. We've got the check solution button so that they can get a brief identification of which cells they've marked correctly and which ones are incorrect. And then show solution, which would then show the actual solution for whichever puzzle happens to be loaded. As far as the gameplay itself, essentially the way that it works here is you use the shift key. So they have the concept of blocks and circles, and so the squares being the blocks and the round being the circles, obviously. So Alt key gives us the cell to make it a block. If we hold down the Shift key, the cell is going to erase. And completed puzzles then should have only circles and blocks as the result. But then the actual rules enter down here. So blocks cannot connect horizontally or vertically. So you'll see there isn't any block left or right or up or down of any block that we have here. Diagonally is okay. It's just vertically and horizontally that we cannot have blocks connected. And the same number cannot be circled more than once in any row or column. So here's a good example. Far right column, you can see we have the number 2 twice. So once we make a block for the number 2 here, then it would be illegal to put a block down there. And circles have to form a contiguous path, so that means they have to be all connected both horizontally and vertically. So just following, say, from the top left-hand corner here, you can see we can easily follow a path. They're all connected. We could follow it down. That's a dead end at that point, but if we went back here, we can still come down this side and go down. So there is a way to follow, the connected circles, the adjacent circles from top to bottom without obstruction. And left to right without obstruction. So that's just the basic rules of the game. So here we are in the assignment instructions. So let's go ahead and open up our Visual Studio now and open up our CSIS 125A folder from the root. And then the first 2 files we want to open are the JPTF Hattori _txt HTML file and the JPF _Hattori _txt.js file. So HTML and JS. So Hattori TXT and there's Hattori TXT JS. So as always, let's put in our name and our date. Almost the end of April here, 4/28. And then of course we'll do the file save as and get rid of that _txt. So we got JPF _Hattori.js. That's our first file there. And now we'll move over to the HTML file. Also add the author and date info there. And do the save as, file, save as. And again, removing the _txt. So it's just JPF _Hattori.html. I assume everybody's got that working okay. So the next thing that we want to do is in the HTML file, just above the closing head tag now, we're going to link to the CSS file, so JPF _Hattori.css. And then the first JavaScript file is going to be the JPF grids 3. So that's the solutions to the puzzles, just like we had in the tutorial. And then the file that we'll be working in, the JPF _Hattori.js. And we want to load both of those files asynchronously. So in the head section here, right underneath of styles, we're adding JPF Hattori as the style sheet. And then underneath of that, we're going to do the JPF grid 3 JavaScript file and load it asynchronously. and then load up the one that we're working on, the JPF Hattori.js right under grids. And again, load that one asynchronously. Okay, so there are the 3 references that we added into the head section there of the HTML document. First one for the style sheet, and then the next 2 are our JavaScript files, the JPF grids 3 being the solution file, and then the JPF Hattori being the one that we're working on. And both should have the async attribute. So now we move into the JPF Hattori file. Actually, they want us to take some time to look at the HTML. Let's do that first. The main thing is, as we saw previously, we've got this H1 heading here, just like we did in the tutorial, that's going to represent the title value. So obviously we'll need to populate that as we pull in each new puzzle. And then it's the figure element, which is ID'd as puzzle, that all of the table elements will be built into, that actually make up the grid there that is the Hattori game. And then we finally here have our 2 buttons at the bottom. They are grouped into an ID of a div that's bottom buttons. The ID for the check solution button is going to be all lowercase check, and for the show solution, it's going to be all lowercase solve. Okay, so those are the elements, obviously, that we're going to be targeting as we set up our JavaScript file here. So now we can move over to the JPF Hattori.js file, and directly below the comments section, declare a global all cells variable, which we're going to use to store the array of puzzle cells in the Hattori table. And we just want to declare it. We're not going to actually assign a value to it yet. So that's pretty basic, right? All we got to do is go in here to our JavaScript file underneath of the comments, and just before we do this, realize that there are some, there's been some code already written for us. So the check solution function's done for us, the show solution, and the draw Hattori have all been done for us already. Draw Hattori right there. So we're working between this comment here and the opening comments up here. So how am I going to declare a global variable called all cells camel case at the point where my cursor is? Somebody help me out here. Yeah, maybe I should just give you all a 0 for this assignment then, huh? Nobody has any ideas how to create a variable there that's just a variable? It's just declaring the variable all cells.
Yeah, called var all cells.
There you go. So var, keyword var, indicating we want to create a new variable. And it's just going to be all capital C cells, because everything's in camel case, right? And then we end the statement with a what? What character do we end our?
Semicolon.
Semicolon. Thank you. All right. So that's our first step there. Let's save as we go. Control S. In step 4 now, we're going to set up a command that'll run the startup function, which is the next function that we're going to build here, when the page is loaded by the web browser. And we want to add a comment for that too, because we should be commenting as we go here. In fact, let me check. Was there a comment for our variable? No, there wasn't. But there is a comment for the loading of the startup function here. So that comment is going to read, write the first puzzle data into the web page. So that's the comment. How do I, if I want, once everything's loaded into the browser window, how would I trigger off a function named startup? Even though we haven't set up the startup function yet, we can still make a reference to it here. So what's the outer object? What's the browser object? How's it represented in JavaScript?
Window.onload equals startup.
Good. So window is our object, right? Dot, then the function, actually it's a method, but onload, right? And then that's equal to just the name of the function that we want to have running, which is going to be start capital U up, and again, a statement, end it with a semicolon. So it's that simple. Again, this is, what enables us to be able to run our code asynchronously now. So as long as the async is put in the attribute there for our script files, it'll load everything into memory, but it actually won't start running the code, processing the code, until the window on load event is fired off by the web browser. So that's a big key, obviously, to being able to load your JavaScript asynchronously. Okay, so step 5 now, and this is how a lot of the instruction works from this point forward. They have the numeric step, which kind of defines what's going to be happening, but then they break it down into subtasks here with A, B, C, D, E, F, etc. So step 5, they want us to add that startup function that we just referenced in our previous line of code there. And the job of the startup function is to display the contents of puzzle 1 after the page is loaded and set up the initial event handlers, meaning assigning the event handlers into the buttons, into the cells as well. And within the function, we're going to add the following commands. So first step, let's go declare the function, and then we come back, and inside of the curly braces for the function, we just start following each of these individual steps here. So right underneath our previous line of code, we want to use what keyword here to declare a function? That's a tough one, I know. Yes. So function's the keyword. We want to call it start, capital U-P, start up. And of course, we need to have parentheses there. We're not accepting any parameters, but you still have parentheses when we declare our function. And then we'll just set up the curly braces so that we can build the body of that function. So just a simple function space, startup, parentheses, and then the curly braces for the statement blocks that are going to make up that function. So moving on now to the next instruction. This is going to be step 5A now. We're going to want to change the inner HTML of the element that's ID'd as puzzle title. So you might remember that was the H1 as we were looking there in the HTML file. So every time that they're talking about changing a value in our HTML document, you want to start thinking to yourself that you're going to need to use the document object and one of its many methods to be able to select the actual HTML element that we want to modify. And then in this case, we would append to that selection of the HTML element the .inner HTML property, because that's what we want to replace. So basically what they're telling us here is which ID we want to target, puzzle title, and what value we want to put in the inner HTML, which is going to be puzzle 1. So that's just, as I said in the tutorial, we're hard coding the values in there at the moment because we know that that is going to be the first puzzle that gets loaded. Later on in our code, we'll have a function that will actually change the title based on the actual puzzle that's being loaded. But since this is just going to run before the user ever makes a selection, and it's always going to load puzzle 1, no problem hard coding that value. So we should add a comment here too. So let's flip back here to our Visual Studio, and inside now of the startup function, I'll add the comment that reads, write the first puzzle data into the web page. Actually, I already wrote that one, didn't I? I put that above the function it's supposed to be underneath. Yeah, the comment that goes above the window on load actually should be this. So that one reads, run the init function when the browser loads the page. And that's incorrect, isn't it? That's what they actually have in the solution file, but startup is the correct name of the function. Okay, so again, just good commenting, good practice as far as coding goes. Put that inside of the curly. There we go. Okay, so our goal here is to now select that puzzle. Go ahead. You're going to read it. You're going to tell me what to do here, Crystal?
Oh, yeah. Can you hear me?
I can. I hear you very well. Thank you.
Oh, is it document.getElement by ID, parentheses, puzzle title dot inner HTML
Correct.
equals puzzle1?
Right. Very good. So again, anytime we need to change something in the HTML document, it's always going to be document dot and then one of its many functions or methods. In this case, it's going to be get element by ID because that's the way we have it assigned in the HTML document. And then in the parentheses, in a string value, just identify that name. And so in this particular case, it's the puzzle title. Right. So that's what gets selected. Now we want to change its inner HTML properties. So we want to append to that with dot notation and then inner all caps HTML. And that's equal to the string value then of puzzle space 1. And that's a complete statement. So once we've got that element, which is that H1 element, we're just changing its inner HTML, the current value that's there, with the value we put to the right, puzzle 1. Save our work, Control S. Next, in step 5b now, we want to call the draw Hattori function using the Hattori1 numbers, Hattori1 blocks, and Hattori1 rating variables, because those are the three that we need to build the puzzle, specifically puzzle 1 here. So those will be the parameters that we're going to be passing into that draw Hattori function. And yeah, remember that the way that the draw Hattori works is we just give it those three values. It goes out then to that other JavaScript file, looks for those arrays, and then pulls in that information and draws the table out for us. We'll also add a comment on this one. Okay, so still working within the startup function, going below the last statement that we added there, adding a new comment, which reads display the first puzzle using the draw Hattori function. And so now we're targeting that next element in the HTML document. So right underneath of that H1 that's ID'd as puzzle title, then we have the div tag that's ID'd as puzzle, and that's of course where the entire table is going to be drawn. And again, we're changing its inner HTML by calling that draw Hattori method and then passing the three values, the three parameters that it needs to be able to actually complete drawing out the puzzles. And of course it's 1 again, and because we want to load the first puzzle. Yeah, let me get this a little bit bigger for you so that you can see it a little better on your end. There we go. Any issues, any problems so far? Anybody? Okay, well that was 5B. So moving on now to 5C. We need to declare a variable named puzzle buttons, referencing the page elements with the class name puzzles, and then loop through the puzzle buttons object collection. And for each button, we want to add the event handler to run the switch puzzle function when the button is clicked. So in this particular case, it's kind of a little bit more involved in the sense that we're going to get a collection, right, of all of the puzzle buttons. And remember, there's 3 of them. So then we have to use a for loop to go through there and actually parse through it. So let's start with the comment and then a creation of a new variable called var puzzles. That'll be the array. So underneath the previous line, the previous statement that we got there. So we've got a new comment that reads add event handlers for the puzzle buttons. And here you can see we're going to declare a new variable called puzzle buttons, and that'll be the result then of getting elements plural by class name. And this is the class name that's assigned to each one of those buttons. So that'll give us a 3-button array, and then we need a for loop then to go through and add the event handler to each one. Before I put the code up there, Crystal or anyone else, would you like to take a stab at what the expression is going to be in the for loop? What's the terminal value that we should use in the for loop?
Yeah, it's for var I equals 0, I is less than puzzle buttons dot length I
Very
plus
good.
plus.
Right, so that's the key. The terminal value here, how long the for loop runs, is going to be as long as I is less than the length of our puzzle buttons. So remember, as we go through the array, we're going to start with element 0, and then element 1, and then element 2, on and on. But since we use the less than operator there, our length, let's say we've got, well, we know we've got 3 buttons in there. So the length in there is going to be 3, but the index, the elements are only 0, 1, and 2. And so that's why we use the lesser than symbol, because we want to end up 1 less than what the actual length is. So length is 3, but we want to end at element 2. And because we start at 0, we still get, all 3 of the buttons. So then you can see that as we go through the for loop, we're using that I, our counter variable, to identify the current button. So button 0, and then next time through the loop, button 1, and the next time through the loop, button 2. And in each time, we're targeting its on-click property and assigning to it the switch puzzle function. So let's copy that and paste it right here. So there's the for loop. There's the counter, the index being set up, var I equal to 0. And then again, the terminal value here, we want to make sure that the loop runs as long as, to get every single element, but not more than the elements in the array. And then just increment our counter variable each time through the loop. And then just a single statement, just for each button that we are at that current point in the loop. Again, use the on-click property and assign to it the switch puzzle function. So that'll give all those 3 buttons their event handler. Let's save our work there, Control S, and then move on to 5D here in the instructions. So the next thing, 5D, is to call the setup puzzle function that defines the initial appearance of the first puzzle. So that's a very simple command. All we got to do is just type in the setup puzzle, open and close curly braces, semicolon, and that calls that function. We are going to add a comment above it there, which reads, set up the initial appearance of the first puzzle. So there's the comment, and there's the simple 1-line command there then to run that function. And that's one of the functions that's already created for us. So that's a pretty simple one. That's step 5D. Save our work with Control S, and let's move on back to the instructions now. Up to 5E, where we're going to add event handler to the check solutions button and have it run the find errors function when that one is clicked on. So in this case, we actually have to go target the button specifically, just like we did up above with the puzzle buttons there, except in this case, we're using the ID value instead of the class name. So right underneath of your setup puzzle statement, go ahead and add a new comment that reads, add an event handler to the check solution button, and then go ahead and write this line of code there using the document dot get element by ID, identifying the element's ID value of check, And again, targeting its on-click property and then assigning to it the find errors function. And remember, when we're assigning these functions, we don't put the parentheses after. Exception would be when we actually need to pass parameters, but these here we don't need to pass any parameters. If you look at the draw Hattori, we are assigning that into the inner well, actually this one's a little bit different because we're assigning it into the inner HTML, which means it actually runs the function and then replaces the inner HTML. Whereas this one here is more of an assignment. It's actually assigning that function name to the on-click event handler. So anytime you're assigning to these event handlers here, that's when you're just going to type in the function name without the parentheses. Okay, one more step in 5 here. 5F, we want to add an event handler to the show solutions button. So that's the other button that we have at the bottom of the puzzle. And that's going to run the show solution function when it is clicked on. So just pretty much identical to what we just did in our last bit of code there, just this time targeting specifically the solve button is the idea on that one. So we will add a comment again as well. This one reads, add the event handler to the show solution button. Then we've got the actual statement here using the document object. It's get element by ID method. We're targeting the solve element within the page. So that's the ID assigned to the button. Again, targeting the on-click property, and again, assigning a function name to it without parentheses because we're assigning it to the event handler. All right, we'll move on to step number 6 then in the textbook here. In 6 now, we're going to add that switch puzzle function. And that switches the page between those 3 different possible puzzles. And that will include an event object as the parameter, because remember, that's how we can identify which button was clicked on. So we'll use that as the parameter in the function so that the function will know which button was clicked on, and then we'll come back here and add all the particulars. So just initially, we're going to create the function switch puzzle and have it accept the parameter of E. Now I got a lot of space here, so we want to close that up because we're creating a new function now. So keyword function, and then the name of the function in camel case, so switch puzzle. There's the E parameter that it will accept, so that'll be the actual event object itself, and then the closing curly there. Make sure we've got a complete function before we start adding things to it. Now, as I recall this step, let me go back and look at this again. I think, yeah. So in this step, what we're going to do is steps A through D here, which is going to be several statements that we need to write out, including a switch case structure. But then once we get all this code written, we'll go back and we'll wrap it inside of an if statement where we're using a confirm dialog box. So remember how the confirm dialog box works is we'll have some text in there that tells the user that if they change puzzles, they'll lose all the work that they're currently doing. And so they'll be able to choose yes or no. If it's no, it just leaves the puzzle the way it is. If it's yes, then it'll go through and actually switch to the new puzzle. So we do all of this, and then we come back and wrap what these statements make in the switch block. We'll wrap all that inside of the if that has a confirm dialog box statement in there. So the first step is to declare the puzzle ID variable, and that will be equal to the ID of the event object target. So that means we'll use that, that parameter E that got passed into our switch puzzle function here. So that's just simply declaring the variable and then assigning it or initializing it with a value that is the E.target ID. Okay, so var keyword, that declares the variable puzzle ID. Notice it is both an I and the D are capitalized there. And then that'll be the results of this parameter that's being passed into our function and getting the actual ID value from that. Save your work as you go, Control S. In step 6B now, we're going to change the inner HTML of the element that has the puzzle title ID. So remember, that's the H1. So just right underneath the previous creation there of var puzzle ID, we'll go ahead and add our document.getElementById. And you can see there, we've got in the parentheses in the string value, puzzle title. So that is targeting the H1. Want to change its inner HTML. And now this case, it's going to be the eTarget value. And if you remember, if we go back here to our HTML, the value of each of the buttons is essentially the name, the title, right? That's we use for each of the puzzles that shows up. So that's why it's grabbing the value that's hard-coded into the button itself. Because eTarget ID, if we go back and look at it, see, is not, it's written as an ID. You couldn't have a space in an ID value. So you really couldn't, you could, but it would look really kind of amateurish if we listed that as the H1 value, right? It looks much better written out like that. Okay, so that was 6B. So now we move on to the switch case structure. That's step 6C here. In the switch case structure, we want to target the puzzle ID variable and load then the appropriate HTML code for each of the 3 puzzles into the page with the ID puzzle. Then we use the draw Hattori function to actually generate the HTML code, and we assume that the puzzle ID is limited to those 3 values that we were just looking at, puzzle 1, 2, and 3. Those are the actual IDs, right, that are assigned to those buttons. So we'll use that puzzle ID then as our value that we pass into our switch block. Right underneath of the document.getElementById puzzle title. That's where we'll add the switch block. So we use the keyword switch, and the way that a switch works is we just pass it some sort of a value, and the value of this variable then gets compared to whatever each case value is. So puzzle ID comes in at puzzle 1, then it's going to run this block of code here. If it comes in as puzzle 2, it runs this block of code. Puzzle 3, it runs this block of code, and you see the main difference, it's IDing the actual table as puzzle in each case, but the real difference is when it calls draw Hattori, it's actually giving it the correct information to go into that other file, the grid 3 file there, and grab the 3 arrays so they can build the puzzle from there. And again, remember with your switch blocks, you always, after the case, whatever the statements are that you want to have associated with a particular case, you always want to add the break statement so that it will break out of that case and then not continue through and also apply these next values. Now this particular one doesn't have a default, which is usually kind of frowned upon, but we know for a fact that we only have 3 buttons and we're going to have one of 3 values, and we're not letting the user type in the information, so it's not like they're going to type it in wrong or anything. So we know that those are fixed values. They're already hard-coded in our JavaScript, so we really don't have to have a default in that case. We already know exactly what 3 values we'll be dealing with. So after 6C, 6D now says after your switch case structure, you're going to call the setup puzzle function to set up the features of the selected puzzle. So this is just like we did kind of back there in the beginning, right? We do the draw Hattori, which draws out the puzzle, and then we call the setup puzzle function so that it basically goes through and sets all the background colors the way that they should be. And I believe this also, assigns the key assignments to it as well, the Alt key and the Shift key. But that's already been written for us. All we got to do is call it. So this is going to be outside of the switch block. So after the closing curly for the switch block there, we'll go ahead and add in both the comment and then just the call to our setup puzzle function. So right between the closing curly for the switch block and the closing curly for the function is where we want to put that code. So step 7 exactly says create the setup puzzle function to set up the features then of the puzzle table. And then go into the function and do all this stuff. So just like we did before, let's just declare it first, and then we'll come back and start adding the individual steps here. So this is going to be outside of our previous function completely, the switch puzzle function. We want to move outside of that function. So after that final closing curly brace there. And as I said, we're just going to declare it at this point. So just keyword function, then the name of the function, setup puzzle in camel case, not accepting any parameters. So just a set of parentheses there, and then open curly and close curly. And then we're going to work in between in the additional steps here. The next step is to use a query selector all method to create an object collection then of all of our TDs. Once we have all the TDs, then we can go ahead and go through a for loop and process them one at a time. So the first thing is just grab them all. And we've got a comment there that reads, match all the data cells in the puzzle. So there's the comment, match all the data cells in the puzzle. And then you can see that we're using the all cells variable, which remember, that's the global variable that we initially set up here, so that it's available to all the, internally to all of the functions, the value of that. So the all cells equal to document.query selector all, and remember how query selector all works. It's quite different from the get element by methods or functions. We can set up our selector more like a CSIS selector now, right? We can be a little bit more complex about how we select things. So specifically targeting the table that's going to be ID'd as a Tori grid, and then each of the TDs, in other words, cells within that table. So that becomes a collection now of all the TDs, and that's being assigned to this variable all cells. So that's what we'll need to parse through then, is the all cells array now, our collection, so that we can manipulate each of the cells as we go through here. And anytime you're dealing with a collection, it's pretty much always going to be a for loop, at least initially. You'll learn later on, well, not in this particular class, but in other classes and with other languages, you'll learn more, like the for each works quite well in parsing arrays as well. Okay, so that was step 7. And 7A. So we're up to 7B. So this is where we create the for loop then. Loops through all the cells in our collection there. And then for each cell, what we want to do is change the background color to white, change the foreground color, which is just color, right, to black, and also set a border radius value to 0. Yeah, so we'll create the for loop. And then we'll do the initial setup listed there. In fact, this has a comment also. The comment reads, set the initial color of each cell to white. Okay, so there's the for loop, and I've got the opening curly here, and I don't have the closing curly, so I need to get that in there. Okay, so again, we created the collection here. It's called all cells. Now we're using a for loop. We want to process through the for loop as long as we're less than the length, the number of elements in that collection. And then each time through, just targeting the current cell, the current TD, and changing its style property, first background color to white, then color property to black, and then border radius to 0. Step 7C, within the for loop, we're going to add a mouse down event listener for each cell in the all cells collection. Notice too, They have set an event listener now instead of the event handler. Because remember that with the add event listener, it gives us the ability to add more events to a single element. So in the for loop, adding a mouse down event using the event listener technique, and that'll be assigned to each cell in the collection, depending then on whether we've got the shift or the alt key or no key pressed by the user. So we'll also have to set up an if clause in here to check to see if any of those conditions exist before the change is actually made. So to start this off with, let's kind of take it piece by piece here. If you recall to the tutorial, when they used the add event listener function, they used anonymous functions to pass the actual code that we wanted to be run in this particular event that occurs, which is going to be the mouse down event. Let me put it on the screen there, and this will help remind you, I think. So still inside of our for block, got a comment that reads change the color with each mouse down. And so here we've got, again, just like we did up here, just targeting the current cell, but this time using the add event listener method and targeting specifically the mouse down, and then run this anonymous function. And so I need to add a curly right there so that everything I type for the anonymous function will be in a set of curlies. Don't worry about the red squigglies. I think I mentioned to you before, I got a spell checker running, and that's just saying it doesn't know that those are spelled correctly. I mean, TD really isn't a word, right? Okay, so we got that part. Now, when we look at the rest of this, the other thing that we're supposed to configure here is to make the determination of the change to the cell's appearance depending on which key or no key being pressed by the user. So then they give us these different instructions here that target each of the keys there. So if we change we want to change the background color to white, the font color to black, and the border radius to 0 if the user is holding the shift key down. If they're holding the alt key down, we want to change the foreground color to black, the background color to white, borders radius to 0. If no key is being pressed down, then the background color is going to be this shade of gray, font color is going to be white, so foreground color, and we're setting the radius to 50%, so that's how they get the circle look when we click on a cell. And then the final one, to avoid inadvertently selecting the text of, or we showed that to you in the tutorial. If you don't use the prevent default behavior function, then it's going to allow the user, as they click and drag through the table, actually select the components that make up the table. So to prevent that, we have to just add that little bit of code that says prevent default. So I'll just take it through here one by one. Starts out with a comment, and then the first grouping is going to be for the shift key. Okay, so we're inside of this anonymous function. Got a comment now, set the background based on the keyboard key, and now we've put in there the first key, which is the shift key. So we're using an if to evaluate the current value to see if it's shift key or not. If it is shift key, it returns true, and it'll run these blocks, these three statements here. If it returns false from this evaluation, then it'll skip down to the next block of code, which is going to be an else if. So if e.shiftKey does not evaluate to true, then we want to check to see, using an else if the e alt key might evaluate to true. Again, that would be true if the alt key is being held down. So if that's the case, we're changing the background color to black, the foreground color to white, and leaving the border radius at 0. And if neither of these expressions are evaluated to true, then we want to have a catch-all. So we'll just add then an else clause that says if neither of these are true, then you just want to set your background color to this gray shade, the foreground color to white, and the border radius to 50%. And as I said, that's what gives you the circular look. And then just one last thing here to add inside of our anonymous function, which is the prevention of the user's ability to select the cell using the cursor. You know, they can click on it, but they can't click and drag. I think I demonstrated in the tutorial there how I was selecting the numbers that were out to the left of each cell. And so what we do there is we just, like we did up above, where we're using because the function is receiving the event object. And so that's what we want to target here, is just on the cells, the TDs themselves, that's the object, just to add to it the prevent default function or method. Okay, so that is all of the anonymous function, which is running.
Oh, I think you need a closing parenthesis and semicolon after the closing break for function.
That is true. I'm just checking to see if we're at the end or not, and we are at the end of the anonymous function. So we don't want to go to the outer function here. We want to go inside here to the anonymous function. And the reason that we do it here is because the reality is this is actually one entire statement. And I put a curly there. That should be a closed parentheses. There we go. Because remember, we opened the parentheses right here. So you have to be able to follow it from that point. So remember that add event listener just takes two parameters, right? So the first parameter is right here. We're saying this is the event that we're listening for. If that event fires off, then whatever's after the comma is the code we want you to run. So we could have had a named function right there and then closed parentheses and then ended it with a semicolon, because all that is a single statement. But because we're using an anonymous function, it just gets a little bit more complex. So you could almost have this block of code here assigned as a function elsewhere in your program. And then here, so you would have just written out whatever that function name was, close parentheses, semicolon. See, that's how you would normally do it if we didn't have an anonymous function. But since it is an anonymous function, then that's how we need to run it. You need to come down here after the closing curly for the function. You still also have to have that closing parentheses, which is the closer to this parentheses up here. And again, the whole thing evaluates as a single statement, and so we have to end it with the semicolon. Okay, so that completes step 7, or does it? Let me double check here. So we got the for loop. We added the event listener. We got the anonymous function. Oh, that's right. No, we have to add 2 more event listeners first. And again, just reminding you, that's why we're using the add event listener method here, because it gives us the ability to add multiple events to an element. So we just did one for the mouse down. So then after the mouse down, we're going to do another add event listener for mouse over. And mouse over also has an anonymous function. So let me go to the instruction right here so you can see the instructions. So this is going to be 7D. Rebecca wants a different mouse cursor depending on whether the user is pressing the shift key or the alt key. So we saw that in the tutorial again. So again, we're going to grab the puzzle cells, and within the for loop now, we're going to change the cursor. And it's going to change, again, depending on which button has been pressed. So we got the first case is the shift key, the second case the alt key, and then the other one's the catch-all. So just make sure that you're outside of the previous statement for all cells I dot add event listener mouse down. So after the closing parentheses, after the semicolon that ended that statement, now we can add in a new selection of all the cells. This time, though, we're adding the mouse over event listener. Again, an anonymous function. Again, we've got if statements checking to see which key is being pressed, and depending on the key pressed, it's going to load one of these, either the eraser or the block PNG file. If neither of those keys are pressed, then it should be a circle PNG file. And then they also add the types out here, which you need to do when you're changing the cursor. So that'll be 7D. And then finally, within that same for loop, we're going to add the event listener now for the check solution function to run when the user moves their mouse up. So the idea is they're clicking on cells. We want to have an automatic check then, because it may be, you know, as they're clicking all these cells here, they may have come up with the solution at some point, right? We don't know when they've got the solution. So what we need to do is every time they click a cell, check to see if they have a solution or not. So that's what the last event listener is going to be, is when they release the mouse, that means they've already clicked on the cell and did whatever they wanted, a circle or a block. And then we want to run check solution to see if maybe they've solved the puzzle at that point. So we're still inside of the for loop to do that. And it's a fairly simple one here, because now we're not going to use an anonymous function, we're going to use a named function. So here is the end of the previous statement, closing parentheses, closing semicolon, going just outside of that, but still inside of my for loop. Just a single line of code, all cells.I, add event listener, this time the mouse up, and then comma, and then this time check solution, we're not using anonymous. That's a named solution, or named function, which has already been created for us. Okay, so let's save our work at that point. Control S. So here it is, step 8. I'm going to create a find errors function, and that will highlight then the incorrect cells by displaying the cell number or the cell number of an incorrect cell in a red font. So to do that, we create a for loop, goes through all the cell collection again, and basically what we're doing is that we're going to check to see the background color. And, you know, because if you think about it, if it's a circle, then the background color is going to be that gray color. But if it were black as the background, that would be wrong. And so we would change the font color to red. So essentially comparing the class name with the background color property to see if the background color property is correct for the class name that's been assigned to that particular cell. Because those are, you know, what the solution has that information as well. So the solution is going to tell us that essentially. And that's, and I mean, actually I got to think about that. No, it's actually, it is just a comparison. Yeah, it's just going to be the RGB. Let me go ahead and put the code in so you can see it here. This is kind of a two-step, right? A and B here. So the first step is going to be outside of the previous for loop. We're done with that for loop, but before the end of our program. So right here, we're going to declare then a function named find errors. We're going to create a for loop to go through all the cells, so you're familiar with that concept. Here you can see is where we're doing the check, and it's a long conditional check that's going on. So the first part of it is checking the current cell to see if its class name is blocks and if the background color is that gray. Or is the class name circle and the background color black. So in either of those two cases, that would be an incorrectly marked cell. See, from the solution, they'll be identified as their class names. That's how the class names get into each one of the TDs. So the TDs actually, in fact, as I'm saying that, I got to thinking we could probably even go in and see which ones are marked as blocks and circles in the raw code, and we could solve the puzzles that way, I believe. I can't remember if I've checked that before or not. But anyway, the point is blocks should not have a gray background. They should have a black background, and circles should not have a black background. They should have a gray. So in both of these expressions here, this is the first expression says that both of these, if both of these are occurring, if it's blocks and it's this background color, then that would return true. Or if it's circles as the class name and it has this background color, that also would evaluate the true. So both of these are representing, if they're evaluating the true, that those are incorrect scenarios, right? Wrong background color for the class name. So if that's the case, then we go ahead and change the foreground color, the text in the cell, to red. That's how the user will be able to identify visually which cells are not correctly marked. So that's the first half of it. In the second part, 8b here now, right here, the red font color should appear only briefly. So that tells you that you want to run that inside of, or call it with the set timeout. Because remember, the set timeout then allows us to run the function only for a certain period of time. So to do that, we'll add a comment, and then we will set up the set timeout with an anonymous function. So we're inside of find errors here. Here's the for loop. We want to go outside of the for loop, but still inside of that function. So this should be the closing curly then for find errors there. So this one here, we've got a comment that has removed the hints after 1 second. Then we use the set timeout function. It's going to fire off an anonymous function, because that's the first of the two parameters that we put into a set timeout. And then the second parameter is how long we want to run that function. So this is going to go ahead, select all the cells, and if the foreground color, which is up here, remember we're setting the foreground color to red, if we're in error, then it just sets all of those red foregrounds back to a white foreground. So after 1 second of viewing this information here, it's going to go back and just set it back to where it should be, or where it was when the user left off before they clicked on the check solution button. And so all of that then is inside of the find errors function. It should end right there. So let me follow this up, because I just realized that we've got one more step we need to do here. And this goes back to step 6, I think it was. Let me double check it. You might recall I mentioned to you that we needed to add a confirm dialog box to run. Yeah, so in step 6, which is the function switch puzzle. So scrolling down here to right here, our function switch puzzle. All of this code that makes up this function, which is down here and ends with the set, called the setup puzzle, all of that needs to be inside of an if. And then the if, the expression that we use for the if is the results of running a confirm dialog box. So the way that it reads is if, open parentheses, because you always use parentheses for the expressions for your if statements. And then we call up a confirm dialog box. and then pass to it the value we want the user to read. So in quotes, going to read, you will lose all of your work on the puzzle, exclamation point, and then after the exclamation point, continue, question mark. So that's the string expression that they're going to see. And so we got the open parentheses here, 2 open parentheses, and so we got the 2 closed parentheses there. That's correct. So then we want to go ahead and create the block then for the if. So open curly here, close curly here, but I want to remove the closed curly from there now and just reposition it till after setup puzzle. So that way everything in here is embedded inside of that if block. Okay, so checking, popping up a confirm box, getting a return back of true or false, depending on whether the user clicks on the cancel button or the yes button. So yes for true, or I think it's okay for true and cancel for false. So if it resolves to true here, then it goes ahead and switches to the other puzzle, whatever button they clicked on to change the puzzle. So that should do it. Let's see if we can go ahead and run this here. JPF Tori HTML browse. Not showing our puzzle. I must have a typo. Let's do an F12 here. Go to console. There we go. Unexpected end of input, line 257. Did I not close everything correctly? Oh, that would be way down here. So that should be the end of this function here. So I've got curly, got an extra curly, it looks like somewhere. Let's double check this. Okay.
Are you missing a curly brace under setup puzzle?
Okay, so I'm coming down here, that's startup. Here's switch. We got the opening curly for the function, then we got the opening curly for the confirm. Then we close the confirm, we close that. So setup puzzle, I got the opening curly, got the for, and then the anonymous function. So the anonymous function closes here. I think that's where my problem is. I got an extra one right there, don't I? No, because that's the for loop. So that's correct. So this function ends there. The for loop, that's what I'm missing, isn't it? So if I close that, it actually closed it all. Let me check the solution here real quick. So this is setup puzzle. I believe this is where the error is. So we got the opener there. Let me come down to the for loop. We got the opening for the for and the opening for the anonymous. And then if open and close, else if open close, else open and close. Then we close the anonymous. And that's the one I'm missing. And then we close the for loop. Okay, so it's right there. It should be right there. Now I'm getting a green squiggly there. That should be for loop open, for loop close. Oh, no, that's not right. That's just the anonymous. That's right, because this is all inside of the parentheses for mouse down. So that is correct. See, it closes parentheses right there. So maybe it's in here. So here we've got a new anonymous function. We're opening it here and closing it here, if I have these correct. All right, so we close that there, we close that there. Then we have the all cells. And then there should be 2 closing curlies after all cells. That's the for loop, and that's the function. Okay, so that's the one right there. Save that. Go back and run our Hattori HTML. Where's my browser? There it is. Okay, so we get the circle by default. If we hold down the Alt key, we get the square block. If we hold down the Shift key, we get the eraser. So let's get this sized up, and then I'll just go through the game for you real quick, just show you what I'm looking for as far as the evaluation. So here's the solution to the first puzzle. This is just a picture from the beginning of the review assignment. Put these side by side here. So we should have a circle, block, circle, 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 block, block, circle, block, circle, 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 block, circle, block, circle, block, oops, block, circle, circle. I missed this one here is a block, and that's a circle. And we got the puzzle solved. So that should work initially. Now let me make an error here and do a check solution. And you can see that that error tile did turn red in foreground color, and it only lasted a second and disappeared. So we'll make that back to being correct. Let's see, show solution. Well, let's make it errored. And then I'll do show solution. So that replaces everything with the correct solution. Now let's try changing our puzzle. We should get a warning. If we click cancel, it stays where we're at. Click again, we click OK, and it loads the next puzzle. So that's how I will be evaluating your assignment.